Okay, so in this video, I'm going to talk about the derivative as a function. So we talked about the derivative at a point, right? If I have a function f, I can take its derivative by taking this strange limit. So the derivative at a is the limit as h approaches zero of f of a plus h minus f of a over h. So we can calculate the derivative at a point by calculating this limit. And so in this video, I'm going to let f be a fixed function. So this is the function I'm going to be taking the derivative of. And for an example, I'll take f of x as x squared. Okay, so this is what I'm going to do on the left-hand side here is general, and this is a specific example, this x squared. So we're going to take this f of x and we're going to create a new function from it. So we've already seen, we've already done that before, right? Like if I had a function f, I could create a new function like g of x, which is 2 times f of x minus 1. And this sort of took my original function and it did something to it, right? It scaled it by a factor of 2 and then it shifted it by 1. So this was sort of our first skill in this class, was taking a function and creating a new function from it. So we're going to do the same thing in this example. We're going to take our function f of x and we're going to create a new function from it. The function is going to be the derivative of x. So it's going to be a new function, which we call the derivative. And we're going to do this, we're going to create this function by doing the same derivatives that we did before at a specific point, but just now we'll think of the point that we're taking the derivative of as a variable, okay? So if I'm creating a function, I need to tell you what the rule is. So like in this example, the rule was I'll take my input, I'll evaluate it at I'll evaluate f at that input, and then I'll double it and subtract 1. So that was sort of the rule. For this example, like the rule is going to be the definition of the derivative. So I need to tell you if I give you an input x, then I need to do some rule to it. The rule is going to be to take the derivative, and that's going to give me an output, right? So the input is x. Sorry, x here. And same thing here, the input will be x. The rule is going to be, I take the derivative, so let me write this as input, this is the rule, and this is the output. So the rule is going to be to take the derivative at x. So if I input a specific point x, let's say I input 2, then I can take the derivative at 2, right? And I do this by using the definition of the derivative. So this is going to be limit as h goes to 0, f of x plus h minus f of x over h. So that's the rule that I do. And if this limit makes sense, then it's going to be some output, which I'll call f prime of x. So it's going to be some number, and I call that number f prime of x. You know, like if I input 2 here, the output might be, say, 5, and then what I say is that the derivative is 5 at that point. Let's do it with this specific example. So if I input x, the rule is I take this limit, right? So I'm going to take the limit as h goes to 0. So now I need to take the limit of f of x plus h minus f of x. And in this specific example, our f is x squared. So I take the input squared minus the input squared over h. And now we can use our limit calculation skills to actually evaluate this limit, right? So this is tending to 0 on top and 0 on the bottom, so I need to do some manipulation. So this is the limit as h goes to 0. Probably the best thing to do is expand this and try to simplify, right? So I get x squared plus 2xh plus h squared minus x squared over h. And so you see these x squareds cancel. And then there's a factor of h. So this is the limit as h goes to 0. I have h times 2x plus h times h. And then I divide everything by h. And so again, it's still going to 0 on top and 0 on the bottom, but you see in the limit, these h's cancel. So this is the limit as h goes to 0 of 2x plus h. And now this is a continuous function in h. So for any input x, 2x is just a number. Once I fix x, 2x is a number. And so this is a constant, and I'm adding this term that's going to 0. And so this is just going to be 2x. And so what this says is that if my function f is x squared, if I take an input, say 5, then the output that I get when I do this rule is going to be 2 times that input. So in this case, 10. In general, in general, the function might be a different function than x squared, but we still go through the same process. For any input, say I give you 5 to input here, I take this limit where I replace x by 5 here, and if the limit exists, then I get some output. And this output is called f prime of x. So now we have a function, so let me write this on a different sheet. So now we have a function f prime of x. It's this machine. It takes as input x, it calculates this limit, and it outputs some output f prime of x. And so this is a function. And if you have a function, you can ask things like, what are its domain and what are its range? The range is going to depend on the specific function f prime, and the domain is as well. But we can say something general about the domain. So when does it, how do I figure out the domain, right? I need to figure out what inputs can I put in here so that this is going to make sense, so that I'm allowed to do this limit. And if you think about that, basically what I'm asking is, what inputs can I put in here so that this limit makes sense, right? So we say x is in the domain of this new function, the derivative of f prime, of f, the derivative of f, if the limit exists. So if this limit makes sense, then we get an output. If the limit doesn't exist, then we don't get an output, right? So if x is in the domain of f prime, if this limit exists, and if the limit does not exist, then x is just not in the domain, okay? So this derivative function might have a different domain than the original function, and the domain is just, it's exactly all the points where this limit exists.